Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. Hello once again, our most developed student. My name is Confident and welcome to our continuation of the exponents and the laws involved. And in the previous two lessons on exponents only, we looked at the addition and the multiplication and division of exponents. Just to recap, we said when exponents are multiplying, for example, let me use something clear to you. For example, a to the power of m times a to the power of n. We said first check the base, then you can say a to the power of m plus n. But please, a to the power of n plus a to the power of n, there is no law for this. There is no law. Why? Because it's adding, and this law is only for what? For multiplication. So don't use that law. And then we said also on division, if I say a to the power of m divided by a to the power of n is same as someone saying a to the power of n divided by a to the power of m n. And the word division, you see there is a multiplication there. You say write the base and then say m minus n. And we looked at some examples, but what I say, ensure that you're subscribed so that you can be notified. Every time I post a new video, you'll be notified. If you're not subscribed, it's going to be a problem. So I subscribe so that every time there is a new video, you get a notification. Now look at this, the zero exponent rule and this proof, the zero exponent rule. Now a to the exponent 0 is equal to 1. Look at that, a to the exponent rule. Let's try to prove it. If I give you, for example, if I say to you 2 to the exponent 2 over 2 to the exponent 2. Now this is same as what? 2 to the exponent 2 divided by 2 to the exponent 2, and you said when you have same base, it's what? 2 to the exponent what? 2 minus 2. Are you seeing that? So what is 2 minus 2? It's 2 to the exponent 0. But now remember, I can cancel out 2 to the exponent 2. If I work it backwards like this, is same as 2 times 2 over 2 times 2. So this 2 cancels this 2, this 2 cancels this 2. Now the answer here is equal to 1. 2 to the exponent 2 divided by 2 to the exponent 2 is equal to 1. And at the same time here I'm getting 0. Hence, therefore, you can see that 2 to the power 0, which is this side, is equal to this side, which is 1. Are you seeing that? So I'm using that. That's the proof I'm having. Can I repeat again? I'm saying, if, let me give another one. If they say 3 to the exponent 3, or let's just say 3 divided by 3. 3 divided by 3. What do you know 3 divided by 3? 3 divided by 3 is equal to 1. You agree with me? At the same time, 3 to the power 1 divided by 3 to the power 1. Because this is to the power 1 and 1. Using the laws is 3 to the power 1 minus 1. What is 1 minus 1? Is 3 to the power of 0. So do you see that 3 over 3, which you got, is equal to 3 to the power 1 minus 1, which is equal to 3 to the power of 0. But we know that this also is equal to 1. Are you seeing that? So that's how you prove that. Alright, but what does it mean? It means any number to the power of 0 is equal to 1. For example, 100 to the power of 0 is equal to 1. Test it with the calculator. 55 to the power of 0 is 1. No matter how big, 1 million to the power of 0 is 1. Bracket, look at the bracket though. Important here, minus a to the power of 0 is 1. A to the power of 0 is, but minus a to the power of 0 is minus 1, because this negative is not affected, unlike here. Just be careful where it is. For example, I can test with the calculator with you to say, if I say negative 2 here, negative 2 to the power of 0, this will give me a 1, but negative 2 to the power of 0 is negative 1. Why? The 0 is not affected. You can test it. I always say test everything with the calculator. Negative 2 to the exponent 0, it's 1. Minus 2 to the exponent 0, it's minus 1. I've seen that. Remember that law. The next law, the best one, exponent, is another law that is common. Don't get confused. 1 to the power a is equal to 1. Remember, 1 to the power 5, for example, it's 1 times 1 times 1 times 1 times 1, 5 times, which is just what? Look, I almost wrote 5, which is just 1. Avoid that. It's multiplying. I'm not adding. It's 1 times 1, which is 1 times 1, which is 1. So 100 to the power 1 is 1. 1 to the power 1 to the power 55 is 1. 1 to the power a million is 1. Minus 1 to the power of 3. Look at the power. The power is what? Odd number. Hence I'm getting minus 1. Minus 1 to the power of 4. 4, we looked at this in the previous lesson. Minus 1 to the power of 4. What is 4? It's even number. If it's even number, you get a positive 1. Minus 1 to the power 9. 9 is odd number, you get minus 1. Okay? And then minus 1 to the power 4. Now, don't be fooled here. The 4 only affects 1. So it's minus 1 here because you did not protect. You see, it's only when there is a bracket here. Look at the two different scenarios. Look at this. Don't allow you guys to be tricked by the examiners. They like this. Look at this. They will give you minus 1 to the exponent 4 and minus 1 to the exponent 4. You can apply here the even number thing to say it's plus 1. But here, because it's still even, but the negative is not protected, it will be equal to negative 1. Are you with me? So be careful of that. Let's go to law number 3. What does law number 3 say? Law number 3 say multiplying the exponents, a to the power m bracket, and you multiply. See, these two exponents, they multiply. So if I say to you, there is an example here they gave. Look at this example. 3 to the power of 2 bracket to the power of 3. Now, this is same as 3. Now, the bracket, you know, means multiplication, but you focus on exponents. You say 2 times 3. What is 2 times 3? Is 3 to the power of 6. That's it. Remember that. And law 3 and 4, they are similar. They are saying if you are given a times t to the power n, this n will affect a and affect t. Are you with me? So if they give you this law to say 2.3 to the power of 2, remember dot means times. This is same as 2 to the power 1 times 3 to the power 1, and you're putting it 2. That's what it means. Then you're going to say 2 to the power 1 times 2 times 2 to the power 1 times 2. Hence, it's 3 this one. Hence, it's 2 to the power 2 times 3 to the power of 2. I made it long, but directly you can move straight to this. To say, this 2 will come there and come there. Since there is a 1, it will be 2 to the power 3 times this. Then you can simplify further. 2 to the power 2 is what? It's 4 times 3 to the power 2 is what? It's 9. And the answer is what? The answer is 36. Or, it's also fine to do this. It's also fine now. 2 times 3 here. 2 times 3 is 6 squared. What is 6 squared? Is 36. Inside 2 times 3 is 36. Alright, so that is that part. Let's look now at a few examples with that law. Look at this activity. Say simplify the following using laws of exponents. So they gave me this one. Apologies for the background noise. Apologies. The children are playing outside, but I had to bring this to you guys. X squared to the power 4. Now simple. That bracket means multiply those two exponents. Multiply them. So it's x to the power of 2 times 4, which is what? X to the power of 8. That's the end. Don't do anything further. It's done and dusted. It's done. What about this one? If they're giving you here, let me write it again. I think it will be better to work it here. To say x to the power of 2, y to the power of 3 bracket to the power of 4. Look at this. Similar, it's the same thing. This 4 will affect that and affect that, but because of the what? Because of this bracket, they are multiplying. Don't forget. So it's same as what? Can you try it? It will be what? Try this. Pause the video here and try it yourself. What will be the answer here? I just gave you the hint. It will be 2 times 4. Y, you can put a times or dot. Y will be what? 3 times 4. That's what it means. Then you get your x. 2 times 4, it's 8. Y, 3 times 4, it's 12. Guys, it's done. Don't force it. Don't try to mix things up. Don't say here you try to say xy. You like, this is xy, and then you're saying 8 plus 12. No, this is not allowed. It's done. That's the final answer here. Finish and clap. C. What is C? C is interesting here. I like it. Look at this. I'll try it with the calculator first. It gave you this. It said and gave you that. It's 2 squared. It's an interesting one. Go and give it to also your friends. Go write this one and give it to your friends and tell them solve this. Let's try with the calculator first. It's a very interesting one. Look at this. If you are going to be solving that, you can also try it with your calculator. What does it say? It say first bracket and second bracket, and then 2 squared, then I close it, and then I've got cubed, then I close it, then I've got to the exponent 4. What is the answer? It's a big number. See this 167772116. Looks small, but it's a big number. What is happening here? This is the first thing you need to do. Work from inside out. Inside out. Avoid outside in. Try inside out. Meaning, start with this 2 here. Pretend that the only ones you are seeing. So it will be that big bracket, which is 2 to the power of 2 times 3. You see, we have opened this bracket. Then you are left with the other one, to the power 4, which is equal to, still put the bracket, 2 times 3 is what? It's 6 to the power 4, which is equal to 2 to the power of 6 times 4. You apply now this bracket, which is equal to 2 to the power of 6 times 4 is what? It's 24. Then if you try that, 2 to the exponent 24, remember that big number? There it is. Alright, interesting, but don't get fooled on that one. What about this one? Also, don't get fooled here. Number D, it's not really difficult per se. Let's look at this. It's not really difficult. It's not really difficult. If I can even make it bigger. It's not really difficult, but you just need to focus. See where they're trying to confuse you. Now let's study this. What is the power of the top M? What power is here? What power is there? Can you try it? Yes, it's 1. You are right. And then with that, try it. What do you think is the next step to do? Just try working this out. As I say, pause the video, work it yourself, and then check your answer. Let's try it. What do you get? Okay, if you tried it like that, this one, there it was multiplying, there it was multiplying because of this bracket. So you had m to the power of 1 times 3 dot n to the power of 2 times 3. Now let's go to the bottom. What did you get? The first one, nothing. It's minus m squared. Then look at this bracket. Now what power is it? It's a bracket affecting negative. Now 6 is what? Is even number. What will happen to that negative? The negative will become positive. So it is times n to the power 6. You see that? You needed to know that 6, it will be minus n times 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 minus n. 6 times minus n. The negative cancels. The negative cancel. The negative cancel. 1, 2, 3, 4, 5, 6. I think I made 7 now. You see, if there are 7, 1 will remain that negative. So they will only what? 6. You see, all of them is positive. Hence, it's now n to the power of 6. Don't get fooled, okay? Then, what do we have on top? We have got m to the power 1 times 3 is 3 dot n to the power 2 times 3 is 6 over negative n squared dot n to the power of 6. What do you do? It's up to you. You can choose to cancel that. It will simply fall off. Or you can use that law of exponent which says, don't worry with this negative, it mustn't confuse you. Remember this minus 1, you can just leave it. Focus on the m. This is what you're having. It's m to the power of 3 over minus m to the power of 2. Similar. N to the power of 6 over n to the power of 6. Remember this, we say it's equal to 1, but I say it's up to you if you want to convert it at this stage. Or you want to go straight away with the loss. Now this m must not, this negative 1 must not confuse you. In actual fact, you can do like this. You can say minus 1 times m. You see that? So that you leave it out. Hence, it will be m to the power of 3. Division means minus 2 over minus 1. You see that? Times n to the power of 6 minus 6. Now, that negative, anything divided by negative, it will be negative m to the power 3 minus 2, it's 1, times n 6 minus 6, it's 0, and don't forget, any number to the power of 0 is 1, which is minus m to the power 1 times 1. The answer is minus m. Alright, not complicated, not difficult, but you needed just to know this. Look at the final part here as I'm ending this lesson. Watch out for this common error. As we said, students like this now because they know this law which says x to the power x times y. Because they know this law, let me not use x, they know the law a times b to the power m. They'll be claiming, since I know that is a to the power of m times b to the power of m. Now they want to apply it like this. When there is a plus, it does not work. A x plus y to the power m is not equal to x to the power. So you can't now say a plus b to the power m. You see there is a plus. Now you can't say now this is a to the power of m plus b to the power of m. That's suicidal of you. Very dangerous. You are a very dangerous person. You see, if there were people who are arrested for breaking maths, you'll be one of them. You'll be locked, my man, or my friend, locked. They will lock and throw away the keys. This is not allowed. Remember, not allowed. Not allowed. I repeat again. If someone says 2 plus x to the power m, you can't say now 2 to the power m plus x to the power m. No. Why? Plus. It only works with multiplication. See, these laws are working with multiplication. Even here, this is wrong. Look, if you say 2 plus 3 to the power of this, actually 2 plus 3 is 5 to the power of 3. 5 to the power of 3 is 125. But look at this. If you are saying it's the same, 2 to the power of 3, 2 times 2, 4, 4 times 2. This is same as 8 plus 3 times 3, 9, 9 times 3, 8 plus 27, and 8 plus 27 is not equal to 1. You see, that's wrong. That's wrong. Don't use that. Last but not least, it is this law, the negative exponent law. What does it say? A to the power negative m is equal to 1 over a to the power m, or 1 over a to the power m is a to the power. So look at what they're trying to say. They are saying if the exponent is negative, very important now, you never did this in grade 8. If the exponent is negative, to get rid of this negative, you say 1 over. Then when you write the exponent at the bottom, is now positive m. For example, if I say 2 to the power negative 3, if I want to remove that negative 3, I'll say 1 over. they need to be 2 to the power 3 now, without a negative. Are you seeing that? Or if I just give you this 2 to the power 3, I say go take this to the top. To take it to the top, meaning that division sign to go is a to the power negative. Then you put that 3. Are you with me? That's how that law goes. And then when you use this law in simpler places, for example, let's say here, they say simplify without a calculator. Test your answer with a calculator. If they say simplify this, 3 to the power negative 2. Now, what is 3 to the power negative 2? To get rid of that negative, you say 1 over 3 to the power 2. Now, 1 over 3 squared, remember, is 3 times 3, which is 9. So you can test it yourself, just to see if you're doing the right thing. So just test that. And what are you getting with the calculator? If you say 3 to the exponent negative 2, look, it's 1 over 9. Are you seeing that? Try this other one. If they give you simplify again, 2, it's 2 times 3 to the power negative 2. Look at this now. This 2, you leave it like that, times this 3, because it is a negative, you say 1 over 3 to the power 2. Do you see that? Now this 2 is same as 2 over 1. So it says 2 times, this is now saying 2 times 1 over 1 times 3 squared. It's the same thing. 2 times 1, it's 2 over 3 squared is 9. This becomes 2 over 9. 2 over 9. Do you want us to test it? Yes, of course, they say test it. It's 2 times 3 to the exponent negative 2. What is it? 2 over 9. Don't forget that. Now watch out for the common error again. They are saying here, be careful. Don't be tricked. If they give you this one, they are saying they give you xy negative m. Now look at this. This negative m, because they said xy, don't say I want to get rid of this m negative. I say 1 over xy to the power m. No. Now what you need to respect is if I say to you xy to the power negative m, and I say to you xy bracket to the power negative m. Those are two different things. Here, the negative m is only affecting y. Hence, when you simplify this thing, it will be equal to x will remain on top, y will go to the bottom. Can you believe that? That's what it does. It works on like that. X remains on top, y goes to the what? To the bottom. So it will be x over y to the power m. But this one now, you can now allow, because of the bracket and the negative m, you say 1 over, you maintain your bracket, which will be x y to the power m. Are you seeing that? This is allowed. Why? Because of that bracket. But if there is no bracket, no. So remember that. Same thing they are saying here. If they give you this, if they say to you 2x to the power negative 3. Now, don't be tempted to go there. I'll make it red to say equal to 1 over 2x to the power of 3. That's what? That's wrong. But you must recognize that the negative 3 only affects the what? The x. So this is same as saying 2. Remember, it's 2 times x to the power negative 3, which is equal to 2 times 1 over, remember that? When I want to get rid of that negative, I say 1 over x to the power of 3, which is equal to, this is over 1, 2 times 1, which is 2 over 1 times x cubed, which is x cubed. If you are now experienced, you are able to just move directly from here to say, if I give you this, if I say to you 2x to the power negative 3, you are able to go directly to say 2 will remain on top over x to the power 3 goes to the bottom. You are able to do that straight away, and it's allowed. Alright, so with that, I'll end up the lesson here, And the next lesson will now focus on typical exam questions on exponents. Very important part now, where I look at as much exam questions as possible. Trust me, if you follow up and you also practice with these questions, definitely you will meet one in your final test. Your teacher won't, you will definitely get one, I promise you. If it's not exactly the same, it will be just a small tweak, but you'll come smiling to say, the teacher wanted to trick me, but I did get you there. You will see your marks going up, and you can even get a distinction after getting this revision. Check it out. Thank you.